If you have any
Okay, you have started?
yeah.
Okay, so this is a question on the rate of chemical reaction. Eh? So just capture the question so that everyone can see it. So we are saying that answer the following questions on the sheet of a graph paper. So to plot this question in an exam, you should have a graph paper. Not wayabulafe apaliponsefu wambobulafishira ulafe. No, it does not work like that. Always use a what? A graph paper. So the question goes like this. Some magnesium and excess dilute hydrochloric acid were allowed to react according to the equation. So this is the equation. You have got magnesium reacting with hydrochloric acid. So now here, what is happening to form these products? This magnesium is more reactive than hydrogen. So it will kick away the hydrogen here so that it can be with the chlorine. So it will be magnesium chloride. Then there is a 2 here. Why? Because magnesium has got a valence to what? How did I know? Magnesium is found in group what? 2. So group 2 elements have got the valence what? 2. So this is a 2 which is here. Of course, the hydrogen here will remain alone as hydrogen in gas. So it is a gas, hydrogen gas. Magnesium chloride, it will be in aqueous, hydrochloric acid in aqueous, and magnesium as a solid like that. So they are saying the volume of hydrogen produced was recorded every 10 seconds. Are we together? Yes. So the volume was recorded every 10 seconds. So this is the volume and this is time. So what to do to answer this question? Always come on your graph paper. Show the graph paper. Show my graph paper here. Then what you are going to do, depending with the numbers that you have been given there are some times that in an exam they will give you the range, the scale. They will tell you that 2 centimeters in the x-axis maybe to represent 10 units. In this case, we have not been given anything, so we are going to come up with our own scale. Are we together? Yes. So, what we are going to do here, you are going to come on your graph, because your graph should be as big as possible. The graph you are plotting, not here, but you just plot a graph just to be on corner here. No, it will not make sense. Or you leave all this space to plot here, it will not make sense. It will not make sense. I always advise learners, you come here, you see that? You leave one box here, and you also leave a box down. The box here and the box down. Then you start here, you put what? 0 as your initial. Then you are going to use your ruler. You draw, this is the y-axis and this is the x-axis. Are we together? Now, listen to me. When you are plotting rate of chemical reactions, you are supposed to put time down here. Are we together? Time should be what? Down here. So here, in the x-axis, you are going to put what? Time in the x-axis. Take note of that. Then here we are going to put volume, because we have been given volume. Right? If it was in the y-axis, yes. If it was mass, which was there, here we would have put what? Mass. Since it is volume, here we are putting what? Volume. So this is what we are going to do. I told you that in the x-axis we are putting what? Time. So when you look at this, let the camera show the people. When you look at this, you have got 0, 10, 20, 30, 40, 50, 60, 70, 80. So if we are to use 10 units to represent 2 centimeters, this box, each box is 2 centimeters. So here what you are going to do, you are going to say, if we are to put 10, 20, 30, 40, 50, 60, 70, 80, it will be enough, right? Yes. So we use that same scale to be 10, 20, 30, 40, 50, 60, 70, 8, right? 8. Use your ruler, always use your ruler. Use your ruler like that. Then this is time. What we are putting down here, it is what? Time. So we are going to put time. Time measured in which units? Minutes. You have been given minutes there. So we are going to put time there in minutes like that. Then we come to the y-axis. You come to the y-axis. Look at what you have in the y-axis. You have got this is 0, 14, 5, 23, 31, 38, 40, 40. So the highest number here is what? 40. The highest number here is 40. So follow me. Look at this. If we are to use the same scale here to say 0, 10, 20, 30, 40, our graph will not make sense. Look at all this space which is remaining here. It will not make sense, right? Because we said that it should cover at least 3/4 of the what? Of the graph. So we'll try to use 5 centimeters to represent 5 units to represent 2 centimeters here. So if we are to say this is 0, 5, 10, 15, 20, 25, 30, 35, 40. You see, at least it has covered 3/4 of the graph. Right? So this scale kind of makes sense. Right? So here you are going to put it 5, 10, 15, 20, 25, 30, 35, and 40 like that. Then you draw a line with a straight line. You indicate this is the y-axis, right? So in the y-axis here, what we are putting it is what? Volume. So allow me to put volume here. Allow me to put what? Volume in what units? Centimeter cubed. Yeah? So this is what we have put here. Mean that you have come up with a scale and you have also indicated the units or the numbers on a graph paper like that. Here it is ending at 40 and there it is ending at 80. You see that? Then our job is easy now. What we are going to do after doing this, we just start plotting. Are we together? You just start plotting. So you'll be saying x, y. So you come here. You come here. You say this is 0, what? 0. So meaning that our first point, it is here 0, 0. Where is 0, 0? It is here. This is 0, 0. You make a point here, a mark. You make a mark like that. Then the other one, it is what? No, let's say x, y. Let's move in that order. X, y. Remember, this is x-axis. This is y-axis. 10, what? 14. Good. This is 10, 14. So let's look at our 10. Our 10 is here, right? Then where is our 14? Between 10 and 15 there. That's where our 14 is. Are we together? Between 10 and 15, that's where our 14 is. So what we are going to do here, when you look at your graph, there are 10 boxes in between 10 and 15. You see that? So which is going to be, this is 10, 11, 12, 13, 14, 15, 16, 17, 18. There are 1, 2, 3, 4, 5, 6, 7, 8, 9. Then this is the 10th box. Yeah. There are 10 boxes here. If you are to count those lines that you have on your graph paper, there are 10 boxes here. So here you will not say that this is 10, then the one which is following is 11. No. Because if it was so, 15 was going to be here, right? So what is happening here is that each box is representing 2 units. Are we together? Because if each box is representing how many units? 2 units. So if we are to say this is 10 here, and I mean not 2 units. So each box is representing 0.5. Are we together? Each box is representing 0.5 and not 10 units. Are we together?
Yes.
Because since how did I know that it's 0.5? I said that tunga 5, right? 5. Yes, there is 5 units in this y-axis. So what I did, I just said, since it is 5 over, how many boxes are here? 10, right? When you say 10 into 5, it is giving you what? 0.5. So this is how I knew that each box is representing 0.5. You see that? So when you come here, this is 10, right? This is 10, 10, but we want to plot 10, what? 14. So here it will be 10. The next box it will be 10.5. Get the point? 11. 11.5, 12. 12.5, 13. 13.5, then 14. Then 14 is going to come. So 14 is going to be just below 15 somewhere there. You just leave one box, then the one which is coming, it is just 14. It will be somewhere here. I'm sure we are clear now, or now we have plotted this one. If you are not clear, for those that are watching me online, you can just go back. You take your video backward just to be clear on what I said here. You are free to repeat as many times as possible. Then let's go to the next point. Let's go to the next point. It is 20, what? 23. So this is where 20 is, comma 23. So you come here. Again, what you are going to do on your graph paper, we said that each box is representing how much? How much? 0.5. So this is it. 10, 10.5. I mean, this is 20, 20.5, 21, 21.5, then 22, 22.5, 23. It will be somewhere here, according to my graph. Don't worry, my graph is not having those to my line, so I'm just estimating. But your graph is going to be accurate because you have got those to my boxes. So yours is going to be more accurate than mine. Are we together? Yes. Let's go to the next point. 30, what? 31. So 30 is here. 30 is here, 31. You come here on 30. Are we together? So just after one box, it will be 31 because this is 30.5, then 31. Just after one box, it will be 31. You plot like that. Then the next one coming. 40, what? 40, 38. So you come here on 40, then you come on 38. So this is 35 here, right? So the next one will be 35.5, 36. 36.5, 37. 37.5, you're going to have your 38 somewhere there, right? Then the one which is following? 50, what? 50, 40, it is here. Just straight forward this one. So you just plot here on 40. Next point. 60, 40. So you come back on your graph paper, you're going to say 60, what? 40 again here. 60, 40 like that. Next one. 70, 40. Next one, it is 70, what? 40 again like that one. Then the other one. 80, 40. Finally, you have got 80, 40 like that. Right? Meaning that you have made these plots. Are we together? Yes. Then what you are going to do, you just connect the dots. That's the only thing remaining here. So you just connect the dots, you just start here. Are we together? Yes. You just start here, you start connecting the dots like that, with a free hand. Don't use a ruler, please. With a free hand. Don't use a what? Ruler. Use a free what? Hand. Okay. Thank you. So this is how you plot in the rate of reaction. Thank you. You can cut for now.